Hi, welcome back to Moose and Chemistry. This is going to be another Hess equation. This one's going to be a little bit interesting and kind of challenging. It says find the delta H for the reaction below given the following reactions and subsequent delta H values. Remember that delta H represents enthalpy. Alright, so anyway, we want these three equations right here, which I'll call like half reactions, to equal this equation here. That's what we want. Alright, so let me go ahead and get rid of all that real quickly, and we'll get down to business. Okay, first of all, we're going to have to flip the first equation. This equation right here has to be flipped. And the reason why that is because we're going to want to get that H2O on the opposite side of this H2O. That's really, really important. Okay, so now we're going to have to take care of that. So let's do this here, okay? So what we're going to do now, let's see here. So we're going to take this and we're going to clear out a couple things here real quickly. I know this is going to take a whip. All right, and we want to get rid of this other arrow too, so we can kind of clean things up a bit. All right, here we go. So I'm going to flip this first equation. So what that means is I'm going to make this, and let me erase it. I'll erase that equation as I flip it. So I'm going to erase all of this, and I'm going to change this to H2 plus 1/2 O2 yields H2O. Alright. So now when we flip this equation, we also have to change that sign from negative to positive. So we change the sign and make that a positive. Alright, now let's see here. So now we want to make sure we can get rid of everything we need to get rid of. Okay, so what we're going to do is this. Do we got one water there and we got three waters here. So we need to have three waters. So we're going to multiply everything here by 3. Okay. Multiply everything by 3 here. So when we do that, we put 3 here, 3 there, 3 there. But when we multiply everything 3 here, we have to multiply this also by 3. Okay? So now, let's see here. That changes this O2 to 3/2. So let's clean up this O2 here. And so now that O2 is going to become plus 3/2. And this is O2. And that's going to give us an advantage. Now, what we've got now is this. You see this 3H2O here? And this 3H2O here? Hang on. Get this right there. These guys can cancel each other out. So I'm going to go ahead and cancel those two out and get this out of the way. So let's get rid of that and get rid of that. And let's change colors here real quickly. And we'll go to green. So let's see here. This is supposed to be a plus sign. Whoops, didn't mean to do that. Hang on for a second. Go back to black here for a moment. And then, of course, let's erase this. This is supposed to be a plus sign here. Well, that was kind of confusing. Okay, now let's change this thing again. And we'll make it green. So these three oxygens are on either side of the reaction, and we can get rid of them now. Okay, so they're gone. We can also get rid of our hydrogens too. So our hydrogens are on opposite side. We got rid of those. Okay. Now we can go and do something kind of cool here. We can get rid of some of our oxygens. So we get rid of these 3/2 oxygens here. And we're going to get rid of this 7. So 7 minus 3 is equal to 4. So this is going to become 4 right here. I just wanted to show you that before I erase it. So let's go ahead and erase that there. All right. And now this is going to give me 4 halves oxygen, which is the same as 2 oxygens, right? All right, now let's see what else we can get rid of here. Oh, we can get rid of our C2H6s. So let's do that. Let's go back to green here. So we can get rid of these guys here and these guys here. All right, so to kind of simplify things for us, what we're going to need to do is just turn this O4 right here into 2. I think that would be best to do that. So we're going to change that into just simply 2. And let's go ahead and make that a 2 there. All right, so now what we got left is we've got a C2 here, and we need to make it just C. And we got an O2, 2O2 here, we got to make that a 2. And we got a CO2, we got to make that a 2, right? So that means we're going to have to multiply what's left over by 1/2. So when we do that, that gives us 2 over 2. But when we multiply that by 1/2, we also have to multiply this by 1/2. Okay? So when we do that, that's going to change our C right there. 2 over 2 is just the same as C. So it's going to just make that C. Okay, and then that takes care of that. So now we have our C's. Now we have to multiply this also by 1/2. When we do that, that's going to cancel that 2 there, and that's going to cancel that 2 there, because we multiply that by 1/2, that's 2 over 2, right? And that's 2 over 2 here. So let's go ahead and erase those. See, Hess can be really interesting. Okay, and then of course we'll get rid of this oxygens too also. This is working out better than I thought. And so we have to multiply this also by 1/2. All right, so now what we're going to do is we're going to add up all, now let's see what our equation is going to look like now. So now on this side we have CO2 all by itself. That's what we wanted to do, and that's a gas. For just a second here. Okay, and then that's going to yield C solid, okay, plus O2 gas. So we made our equation. Now we need to add up our delta H's. So we have to multiply this one by 3. So we're going to take 643 times 3. That's going to give me 1,929 here. Then we're going to take 190 and divide it by 2. Times 0.5. It's going to give me 95 here. 0.3. And then we're going to take 3,571 times 0.5. Okay. That's going to give me 1,785.5. All right. Now, let's look at this again here. Make sure we got everything that we want to get done. Let's see here. So we're going to get 1929 plus 95 plus 17. So let's see here. Judging by these numbers, what we're going to get 1,929 plus 95.3 plus 1,785.5. This is going to give me a delta H value of 3,809.8 kilojoules, and that's our answer. This is how we do it. Pretty simple, I guess. Let me make that a little bit better there. It's just been a really interesting problem here. Let's just complete the line there. This will give me 3,809.8 kilojoules. So let's go back and double check to make sure everything looks right. All right. We were to take and multiply. We had to multiply the top one. We had to flip the top one and then multiply it by 3. That gave me three hydrogens and 3 halves oxygens and 3. So we were able to cancel out our waters. We were able to cancel out our hydrogens. We canceled out our C2H6s. Multiply this by half to cancel out that 2 to give us a C. And multiply that by a half. Yep, that's it. You guys be snarly. We'll see you back here at Moosing Chemistry. And remember, Hess is always fun.